Thank you for coming. First of all, I have to apologize. I'm sick. I have no voice, so I have to speak with a very low volume, and if I'm coughing, I hope you don't explode. Well, yes. Our project is called noto-hinted. It's basically my project, but it's in collaboration with him. Google started to commission fonts. First of all, for hinting for fonts, for Indic fonts, for Noto, and this was successful. Then it asked for more scripts, hinting for more scripts, and even more. And this kept me busy for the last 2 or 3 years. And somehow we need to find a solution to check the results. Because the normal environment I'm working in is GNU Linux, and the very issue is the testing on Windows fonts, how various Windows rendering engines render the fonts. To let people check the fonts, there must be some easy access to the fonts. So my idea was to do something automatically. Maybe a program which can do snapshots, and this will be then somehow presented. And I started this about 2 years ago. I opened a public repository. I'm sorry. I opened a public repository. The nice thing of GitHub is that you can also have a HTML view of all the pages that are incorporated into the repository. I also added to the project the hinted versions of the Noto fonts that have been commissioned. And then I looked around and I found a company called BrowserStack, which is sitting in India somewhere. And they were so kind and gave me an account so I can use the tools from BrowserStack to get snapshots. I've selected 3 versions, Chrome 42, Firefox 37, and Internet Explorer 11 on Windows 8.1. I selected this relatively old version because you have still the old ClearType mode and a bit more recent ClearType mode to view the fonts. And even, if I remember correctly, the old non-ClearType mode for viewing fonts only in grayscale. The idea was that you have a bunch of templates, and there is some program or whatever that generates the HTML fonts automatically on demand. The demand means if you have a new font or a small bunch of font family with some members of it, that the new pages are automatically generated without any further problems. I just show you what the result actually is. It's like this. This is, hopefully I press the right button. Yes. This is this web page. It's very simple. It's just plain HTML. Actually, I hate programming in HTML, so there's no any further CSS. This could be done more beautiful, of course. For example, now, Noto Sans Hebrew was one of the commissioned fonts with hinting, and I selected the unhinted version that is right now on a repository, available from a repository, the Noto fonts repository. For some fonts, on this, in the same repository, there's also an already hinted version with another program. I don't know exactly what are you using for hinting? For the fonts in the hinted directory. Do you know what hint has been used?
Nope.
Nope.
I'll talk about that later.
Excellent. Good. Then ttfautohint provides different modes to hint fonts. And one mode is the mode G, and one second one is GGD. GGD is easily explained. This means strong hinting for all possible modes. Strong hinting means that ttfautohint tries to align stems and similar things as much on the grid as possible. There's a slight hinting that tries to align lines on some discrete values, not exactly integer values, but maybe 1.5. And lines which are in the vicinity are also aligned on this 1.5, so that you get a certain kind of slight harmonization. And as you can see, here's Hebrew and Yiddish at the same time. The reason is that for some scripts, let's say Latin, it is not sufficient to have just seeing an English text, because you have diacritics to test. For Latin, for example, I have chosen English, of course, Czech, and Vietnamese, for example, so you can really see how accents are rendered. Now let's go to that. Let's say this one, GGD, for example. What you now see is the rendering on this box. This is the rendering on this computer here. It's in the background, it's using a web font, and it gets displayed by this is a Mac computer, by the Mac computer. And here you can then also have a look at the images created by Browser Stack from, for example, Windows 8.1 using the Internet Explorer. Then you get this image. Then you can really check all up to the smallest sizes whether the rendering is okay. Oh, how do I go back? Oh, thank you.
One more?
Oh, it's okay. Then you have the same thing with Firefox, and so on and so on. So this you basically have a. No, it's closing actually. This means you have for a font at least 3 snapshots. If you're even maybe a 4th one, because there's some fonts come with a hinted version also, not by ttfautohint, and you can switch and check that for everything. So this is the basic idea, and you have now shown the results. And yes, later on I will tell you how I did it.
Okay, so this is me. I just thought it would be nice to have a picture of myself. So Werner knows what he's doing. I don't. But I thought, well, it could be fun to play around with it, and so my part will be about my experiences. Experiences with what specifically? So let me first tell a bit, why are we doing this at all? Why are we Google paying Werner to do hinting? Well, we have this project, Noto, which probably you all know, which is about let's get rid of tofu. Like no more boxes, let's just make a font that works for all languages globally ever done by humanity, covers all of Unicode and is all perfect and wonderful. And well, people, not everyone has like a retina screen, so we have a problem, which is that the problem is that people somewhere in Cambodia or whatever, if they have a cheap phone, we made a font for them, it's cool. But it doesn't read beautifully because it doesn't have hinting. Now, do we want to have manual hinting for all of Noto, for all of Unicode? That would be a lot of work. Perhaps we could increase the coverage of auto-hinting so that we have automatic hinting for all the languages. So, you know the Unicode site, right? So that's a bunch of scripts. Looking at it, it's not quite a few, but not that many. So what would it actually take to just do them all, right? So let's, I should go back. For the important ones, and we'll talk about which ones those are, we've paid Werner to do the right thing. And at some point I thought, well, so what do we do now? Can we do we do more contracts, more contracts? How much work is it actually? Or maybe we could just perhaps compromise a little bit on the quality. It's probably not the right audience to say that, but just do it and ship it, and if somebody complains, hope that they actually tell us, and then we fix the problem. And so I'm going to describe what I did by picking a random script here, Kayali, which is, well, what is Kayali? You find a little bit of information on Wikipedia. So it has, one side says about 200,000 speakers, on another one it says it has 600,000, so in that order of magnitude, written left to right, and this is how it looks. And that's pretty much all the information you find online, which beyond Noto. Like Noto is like an excellent reference, so if you guys want to design a typeface for this, I would warmly recommend to look at Noto, see what they did. It's OFL 1.1 licensed, so if you have an open Libre font, you can just take it and copy it and tweak it. And otherwise, if you do something not compatible with that license, it's at least a reference that you can use in the same way you can look at other typefaces. And yeah, so here's the Unicode chart. You see like some Omniglot has a little bit. So how do we hint something like that? And me being the Labrador without any clue, I just want this to somehow look reasonable without making a PhD in glyphics or whatever. So let's open the thing in glyphs. So you see all the glyphs that it covers, which isn't that many, right? Just a few. And you see some combining characters. And we're looking at, now I'm going to tell what you can look at in the script, and then what Werner wants for his code. So left-hand side is like a little bit of staring at the glyphs for a few minutes. You see there's like, which are the blue zones is basically the question. So which are the zone which is something equivalent to x height in the script? Does it have ascenders? Does it have descenders? And when you look at the glyphs, it's kind of Latin-ish, Latin-inspired. So again, probably not the right term, but things do have ascenders and descenders here. So let's find them, and for each category, let's find some glyphs that would be good for finding the top line, round ones and straight ones for finding the baseline, finding ascenders, descenders, and some scripts in Southeast Asia have very large descenders, like Thai is another example, so let's find some of that category too. And to the right in green is the patch that is sent to Werner, and it has a bunch of problems, and Werner is going to talk about them. So this is like the only information that ttfautohint really needs. It's like a bunch of strings, typically single characters, but sometimes it can be multiple characters that can be used for finding the ascenders and descenders and top and bottom, so basically the blue zones. And then a little bit of glue that tells, okay, here we have like the ascender, and this is actually search from the top, and here we have the descender. For this it has no flag, so it searches from the bottom. This is like this is half the change for the script. Another thing that we need for auto-hinting is this thing here. So it needs to find the stem width. How do we find the stem width? We need like one character or two or three that have a very simple shape that we can look at. So, and for some reason it wants it in UTF-8, so it can have it in UTF-8. And a bunch of flags that are sort of pretty straightforward. That is the script code. Another, and actually the last piece of information, is the Unicode range. So, which is the Unicode range for Kayali? Well, that thing here, and this is how it is terminated. And something that I forgot in doing here that I should have done, is if when you look at the Unicode chart, some of the code points are combining characters, and there's also a database for that. ttfautohint needs to know that, so we should have told it that which the code points are that shouldn't be used for, that shouldn't be hinted.
Blue zone.
That shouldn't, yeah. So, yeah, bug here, we'll fix it. And some gluing, and that's it.
Before I continue, I want to criticize some of the patch.
Yeah, so I'm the Labrador, so I'm clueless. He knows what he's doing.
Yes, the idea of computing blue zones is that you have flat shapes and round shapes. And flat shapes are used for the flat blue zones and round shapes for the overshoot blue zones. And here you can see, whatever, wrong key. Yeah. Here you can see 1, 2, 3 with a flat top, and then 1, 2, 3 characters with a round top. This is nice, this works just fine. Then you can here see for the bottom 1, 2, 3, it's also okay, 1, 2, it's also okay, and this is probably not okay. This is simply too small, and there are fonts that don't have a flat shape here, but use a round one.
So this, you actually can see that in the Omniglot chart, that this one, it's a numeral 5, which here has a little tail shape, a curved shape at the bottom, and not, whereas this one here is not curvy. Which actually is a general problem. Like, we now define heuristic for automatic hinting for all of Unicode, for all the fonts globally ever, and who knows if it will work for other fonts. We're testing it with one single font, which might make all kinds of assumptions. Answer to that, too bad, file a bug, and then we can look at it.
This is a quite easy problem, but just for example, have a look in the Unicode charts for glagolitic fonts. You will see glagolitic in a Bulgarian version has round shapes, and if you look at the Croatian version of glagolitic, you will only find boxy. And now you have to, boxy glyphs, and now you have to find a compromise, a set of characters that can be used even in the worst case if you just have only boxy shapes, or which also works for that case if you have only round shapes. This is sometimes the most time-consuming thing, to analyze that and find the right characters. He has sent me a bunch of scripts, and because I'm sick, I'm not as fast as usual. So I will work on the patches script by script and slowly integrate them.
So actually, maybe we can quickly talk about the state we have now. It's Noto, the phase that is shipped, covers all of Unicode 6. And I think we've pretty much auto-hint, well, once you've merged the patches and fixed all the horrible bugs that I made. Thanks, by the way. So we'll be able to auto-hint pretty much all of it, assuming it actually is hintable. Like some scripts, like linear A is an example, at least for Noto. So who knows what the other 5,000 linear A fonts will look like. It doesn't really have blue zones. Like when you look at it, each glyph is sort of sticking somewhere else. And admittedly, how important it is to auto-hint linear A, I don't know. Personally, I care more about the scripts that living people speak. And those we should have covered, I think, exhaustively. At least that's the goal. And if one is missing, then we'll handle it. Next, the ongoing phase of Noto will cover all of Unicode 9. And once we have a batch, I think we'll just do another round of this exercise and then just try to auto-hint all. But if you're the audience, basically, of this tool. Like, if you notice problems, please do tell, because, yeah. Werner is going to speak about how we test this.
So, continuing the critics here.
Oh, sorry, more bugs.
I do this on purpose so that you know what is important here. We have just talked about the shape here, which is not suitable because it can be round or half round, or maybe in some designs it probably goes below the baseline, so it has no use to use this character to define the bottom baseline at all. The next one here, ascenders, this and this is just fine, but here again, it doesn't make sense to have such spiky features like this for defining a blue zone. There must be something horizontal. And again, I can imagine a design where these two glyphs are much higher than the round glyphs in some funky script version, whatever. So it doesn't make sense here to include these two glyphs. The next one, for the descenders, again, this one and this one should be removed. The other four are just fine. This script doesn't have any descender with a flat bottom, so it just has round. Well, this is it. And the final one, this is okay, but I have to mention that in Noto, the positioning of the, I don't know what are these, accents or whatever, or tone marks are done with GPOS table. The ttfautohint program uses half-bus to analyze the whole composite glyph, but ttfautohint itself can't use information of the GPOS table for creating hints. So if you have an application that uses GPOS for positioning accents, you have to rely on the fact that before doing that, the hint glyphs are somehow aligned to the grid. This is the usual thing what ttfautohint does. Another solution, which definitely works, is that you replace these three glyphs by some other glyph, a ligature. Then ttfautohint will automatically hint the ligature correctly.
So this illustrates, again, the problem we are facing, that we are defining heuristics and testing them with one single font, and we don't know how it will perform with other ones. Maybe when you do your font for this script, it will do all kinds of fancy things and the heuristics don't work. Again, please tell.
Then here's nothing special to say. In case you really want to add a script, just look at the examples that are present in the corresponding source files and somehow adjust your new stuff to be similar. In case of doubt, write me an email. So, and now back to the project for generating the noto-hinted web pages. I use GNU Make for doing that. Yesterday, I've seen there was a small session for introducing people to scripting. And if you do scripting, in my opinion, one of the most valuable tools is the program called Make. So all people who are afraid of the command line probably should now leave the room, because it's getting quite technical now. I'm stressing the labs part of the conference. The idea of the make file is quite simple. You have a bunch of prerequisites. Usually these are files. And you have a target. In most cases, this is another file. If one of the prerequisites is older than the target, you should execute the recipe. The syntax is like shown here. Target, a colon, then the prerequisites. The next line, you have to start the line with a tab character, and then it's followed by the recipe. If you don't like that, there's an alternative syntax. Instead of the tab character, you can write a semicolon and then the recipe. Somehow, you have to make the recipe dependent on the prerequisites. So, to say in other words, to get information what has changed and what's the target, you have to bring that into the recipe. And the three major automatic variables are this, this, and this. This one is the current target. This is the first prerequisite. In most cases, you need this one. In case you're a programmer, just imagine you have a C file, and it's the first prerequisite, and second is the header file. The compiler compiles this one, and the header file is automatically included. And if you really need all prerequisites, there's also this option to get them. Sometimes a target is not necessarily a file. It can be just a tag. For example, you say make PDF or make HTML. And such targets are called phony targets, and there's a special rule where you should add the name as phony targets. It's not really necessary, but it makes life easier so that they get registered and they are just working as expected. The next step is variables. As any system, you need somehow to tell how to tell parameters. And the easiest thing to have a variable is this one. Of course, usually assigning. And you have a second one, colon equal sign. This is a very, very important distinction because I will show you later on why this is so. The first one gets delayed until the final execution of the recipe, while the other one, this one, gets immediately assigned. Another possibility, for example, is here you have plus to append something, or here you can set the variable foo only if not defined earlier. For example, you can, on the command line, you can pass a variable to the make file, and if you pass that, this overrides any setting here. Then, variables are not sufficient. You have functions, built-in functions, which use this syntax. You start with a $sign, you have a parenthesis, the name of the function, and then you have the arguments, which are separated by commata. Usually, the arguments are space sensitive. This is after the first space, the arguments, spaces after the arguments are retained and not dropped away, not skipped. Then we have also macro definitions which look like that. Within a macro, you can have arguments. So the first argument is $ parenthesis open 1 parenthesis close. This is nothing special, and calling a macro is also quite similar to the above. There's a special function is called call, which accepts macro as a name, then first argument, second argument, and so on. This is nothing which is surprising. Now to the phases of make. First step is make is reading all make files, that gets included. Scans all immediate variables, they get expanded. Then it constructs a dependency graph. This means if A is dependent on B if base depending on C, C is depending on D, and so on. It builds a graph that all targets are built in the right way. The order of targets is not predictable, which makes it sometimes difficult to write race-free make files, but in most cases, if you have enough dependencies, this shouldn't be a problem. And then there's the second phase. After determining the targets that must be rebuilt, let's say you have changed a source code, then of course the final binary must be rebuilt. Make finds this out and it calls the recipe. Before doing that, all variables are substituted in the recipe. In particular, the deferred variables are now expanded, not earlier. Recipes in general are shell syntax. This means you have two different syntax forms in a make file, which is unfortunately a bit hard to grasp, because in most cases, the normal shell, you have, as can be seen here, you have to write, if you want to access a shell variable, you have to write the $, whatever. And the make variable usually is $, open, variable name, parenthesis close. You get used to it. Now, we are coming slowly back to the project. For example, here's a rule to generate a true type font with ttfautohint. Here you can see in this subdirectory you have this font should be created, noto-Sans-Hebrew regular, in the variant G, hinting variant G. This of course depends on noto-Sans-Hebrew regular, the unhinted one, and it also depends that the directory noto-Sans-Hebrew actually exists. Please ignore that for now, for the details. It just tells you this line tells you that this must be present. It's not necessary that it gets rebuilt. As you can see, lines are continued with a backslash at the very end. And I just inserted here something to get it more easily visible. Then, this is the executable. I'm using an abbreviation. I have a variable assigned somewhere else in the beginning of the make file that says the ttfautohint is located in directory foo bar / whatever. There are some additional flags, whatever they are, it's not important. And then, to construct the G, I pass the flag G to activate this strong hinting only for clear type, old clear type. And I also append here another argument that makes to give this font a different name, namely appending -G to the font name, so that you can have two fonts in parallel, because sometimes the system gets confused which font is which if you have two different fonts with the same font name. And then you can see here finally you can see the automatic variables. The first one is the target. This is noto-Sans-Hebrew, this one. And the second one is this one is the first prerequisite, noto-Sans-Hebrew regular, and this one is the target. So this is the in file, this is the out file. I could have used also the names directly instead of the automatic variables, but this makes the rule very special. The idea is to have one simple rule that can be applied to a lot of cases, because this general rule, what you see here, this basically fits to all fonts, not necessarily only noto-Sans-Hebrew. Some other nice things what GNU Make provide up to is these functions which I show you soon. up to now, this is just basic Make, and GNU has some additional features that makes it quite interesting. In particular, it provides a function called eval. With that, you can programmatically define new targets. This is, I can have some code that generates a target. Normally, you can't do that. Normally, a makefile is a static thing. What can change are the C files, the binaries that you are creating or whatever, or the PDF, but you can't change the rules in normal makefiles. With GNU Make, you can do this. The argument is parsed twice. You have to know that, but you can create a new rule. Then, of course, it expands the function set with a looping construct for each. In this case, this basically means you have a variable that gets piecewise assigned. List, for example, is ABC. Then it first executes the loop with A, the second then with B and the C. And in the end, you have the text that gets applied by 3 times. First time with A, second time with B, third time with C, for example. There's similarly a rule to filter out arguments, for example. In this case, you have a pattern. For example, let's say the pattern is called blah blah. Then you have a text that contains fru fru, mimi, blah blah, boom boom. Then you get the string without the blah blah. This gets filtered out. And another function which is quite useful is to strip leading and trailing whitespace. I'm a big fan of adding whitespace to get better formatting and make everything readable, but as I told earlier, Make is usually sensitive to spaces, so if you use these functions, space gets properly removed. Okay, now the the major function is called font family. Here you have a typical call. Note sans Hebrew, we have regular and bold. Then the tag is, the script tag is Hebrew, and we have 2 examples, namely Hebrew and Yiddish. This simple line is that what the user has actually to insert. And now I show you what it's generated by this simple rule. As you can see, it generates the hinted fonts in various flavors for regular and for bold, so it makes, in total, it makes 4 fonts. Then it creates the web pages that shows me the unhinted, the manual, hinting with the G variant and the GGD variant. The same is happening for bold, so you get 16 HTML files. Then it creates PNG snapshots, namely in this case you can see regular for unhinted variation, Hebrew, with this browser, the next one, then you have the same with this browser. So this makes 24 files in total. This was a list of actual functions, actual files that get generated. Then this function also generates, to do that, it generates a set of rules, as shown before. Here you can see the rules to generate the hinted TTF from the unhinted one. This gets repeated. Another rule is built for not only for regular, but also for bold. Then here's the rule, for example, to generate an HTML file. It uses a template. It's called waterfall.html.in, which is present in the repository. Then it's using a sample text. For the sample text, I'm actually using the noto-tools repository that contains a bunch of sample scripts, usually the first one or first two sentences of the United States Declaration of Human Rights, which is, as far as I know, available for a large bunch of scripts and languages. And I have omitted the actual recipe because there's a lot of technical code which is too complicated to explain here. The next rule here for the first image, again, you see the dependency on the HTML file because the snapshot is actual a snapshot of the HTML file, so you have a dependency on that file. It's also dependent, this is the description file necessary for accessing the browser stack interface. And again, it's necessary that the directory noto-sans Hebrew exists. And here, the recipe itself, I've also omitted getting the snapshot, downloading it, and adding some labels to have a nice view. And then finally, the PNG file has to be a bit messaged to have a nice outlay. Then, we also need to construct the index file itself, as you have shown in the very beginning. You want to navigate somehow to the various scripts, noto files for the various scripts and languages. Again, I'm omitting that now. This is just here for completeness. And now, this is the code itself. I will just start just a bit one to avoid sleepy faces. Here, this is the main thing. The font family macro is calling eval. It's calling this same font family as a same macro with a final underline character, accepting 4 parameters. To make it more readable, I'm using variables here, you see, family, style, script, and language. Then there's a for each loop. First of all, it calls this macro, another macro, which checks whether we have a hinted font version. If yes, there will be another page created so you can compare the hinting with the original one in the Noto repository and the one created by ttfautohint. Then you have the next loop, which creates for all hinting modes the proper TTF files. Then you have another loop in the loop, which creates the HTML files for every language. And then you have another loop in the loop, which do the same for the browsers. So it's just a nested loop of loops, and everything gets built automatically. I'm continuing here. The index is the same thing here, the rules how to build the index. Again, we have a lot of for each loops to create a list of HTML references. Here you can see, just to scare you away, this is set a stream editor to some regular, to handle regular expressions. You can see it's quite common to have in templates to have something which is surrounded with an @ character. This gets replaced with something. So you have in the template you have the entrance top surrounded with @ which gets then finally expanded with the actual value of this directory, and so on and so on. I'm skipping this. And finally, the same is done here to actually call the snapshots.
2 minutes.
This is not important. There's a top-level function which actually builds the final index, top-level index. So this is then actually the contents of the make file. You can see there are some, here you can see the variables. This is my personal setup, for example, where is the noto fonts Git repository with the hinted and the unhinted fonts, and so on and so on. Well, for example, you want to add tfautohint. This is something which I will do as soon as the next ttfautohint version will be published. In the previously seen GNU Make file, you can see here the lines for font family, calling the font family macro, and you simply add this one. In the Noto Tools repository, for example, the demo text is stored in this funny looking name. Whatever this is the language for tfautohint. This is the tag for the script. So you need to have font family, the name of the font. In this case, there's only regular available, the name of the script, and the name of the language. Then you say make HTML. All HTML files are created. You have to commit them to the repository so that they are available in the public. Then you say make. The repository, the screenshot application accesses the public available HTML files, creates the snapshots that get downloaded, and finally you have simply to commit the new images and you're done. So the final step for the user in this case is just adding a single line and execute these minor steps. That's it, basically. This is the official part, and now, because some people have asked me, what about news in FreeType or ttfautohint, I'm just closing this now with, the current release was done in November. It brought a bunch of new scripts, and perhaps the more interesting thing is, even if you have a font that contains glyphs that are not possible to, how shall I say, to be applied to blue zones, it's still possible that ttfautohint can apply hinting to them. This means, for example, for simple font, that lines which are horizontal are, if possible, aligned to the grid, even without blue zones. So if you have a font without a simple font without any, how shall I say, any blue zones capabilities, just call ttfautohint and you get some sharpening at smaller resolutions. This is a new feature which was hidden in all the releases which I've now make the default. A new release will follow as soon as I finish these bunch of scripts. I'm halfway through, but still some are coming. The same is for FreeType. All scripts for ttfautohint, this always stays in sync with ttfautohint. So I'm doing it even the opposite way. First, scripts get committed to the FreeType repository, and then I'm moving the stuff to ttfautohint. Again, there will be a release quite soon as I've there's one final bug somewhere hidden, probably, which must be checked. And the most important information is that variation font support in FreeType is complete. So only one feature is probably missing, and this is a topic which I have to discuss with other developers. I'm not sure whether it makes sense to have the stat table in FreeType. Maybe it makes more sense to have it one level higher. So this is not quite sure. And another pet for some developers, the random operator of the CFF specification is now working also with a new engine. So you can also set the seed. So it is, of course, it's pseudo-random, and by setting the seed, you can exactly control what shapes you get. That's it. Thank you for listening.